In this lecture, I would like to explain about the structure of interhalogen compounds. In the previous lecture, we explained the general properties of interhalogen compounds. So, what is about the structures of interhalogen compounds? Structures of interhalogen compounds are to be explained on the basis of VSEPR theory, that is valence shell electron pair repulsion theory. The main steps involved in predicting the geometry of a molecule on the basis of VSEPR theory are explained in the case of oxyacids of chlorine. On the basis of the VSEPR theory, we know what is the structure of oxyacids of chlorine. So that same phenomenon is now applicable for interhalogen compounds. The structure of interhalogen compound is also explained on the same concept, that is valence shell electron pair repulsion theory. So let us apply the VSEPR theory to predict the structure of interhalogen compounds. So first type of the interhalogen compound, it is XY type of the interhalogen compounds. And the example of XY type of the interhalogen compound, it is ICl, BRF, CLF. Okay. So XY type, in XY type of the interhalogen compounds, Y is more electronegative halogen and X is less electronegative halogen. So let us explain the structure of ICl, iodine monochloride. So first of all, let us see the electronic configuration of iodine and chlorine. Iodine atomic number 53, having the electronic configuration, outermost electronic configuration 5s to 5p5. Chlorine, outermost electronic configuration 3s to 3p5. So both are having 7 valence electrons. So iodine having 7 valence electrons and chlorine is also having 7 valence electrons. Now in interhalogens, since both the elements involved in bonding are halogens, both the elements are halogens. So we can consider the outer configuration of halogens as NH2NP5. That is the general electronic configuration of the halogens. NH2NP5. NH2NP5, it is the general electronic configuration of the halogens. 7 valence electrons are there. So let us draw the Lewis dot structure of ICl, iodine monochloride. So iodine is having 7 valence electrons. So let us show the valence electrons by the cross 1, 2, 3, 4, 5, 6, and this is 7. The same number of the valence electrons for chlorine 1, 2, 3, 4, 5, and 6, 7. Okay. So iodine is the central atom. So on the basis of this Lewis dot structure, we can determine the steric number. So first of all, represent that molecule in the form of Lewis dot structure. So you can see here, these electrons can be shared. So there is a formation of one covalent bond. So in iodine monochloride, number of bonding pairs are equal to 1. And number of lone pairs, 1, 2, 3. 3 lone pairs are there. This is 1, this is 2, and this is 3. 3 lone pairs are there. So number of lone pairs equal to 3. And steric number, it is equal to steric number, it is equal to 1 plus 3. So it is equal to 4. Steric number, it is equal to 4 here. So you can see. So what is the type of this molecule? We are having the general formula to represent the molecule on the basis of the steric number, on the basis of the central atom ABMEN. So here n equal to 3. Okay, number of lone pairs are equal to 3. M equal to 1. Okay, so the structure of this molecule, it is this is the type of the molecule AB3E type. Okay, AB3E type of the molecule. and not AB3E, it is ABE3 type molecule. Number of lone pair electrons are 3 here, so ABE3 type of the molecule. So for this molecule now ABE3, number of the lone pair electrons are 3. So we have to, as the steric number it is equal to 4. So indicates that the expected geometry of the molecule is tetrahedral. On the basis of the steric number 4, the expected geometry or predicted geometry it is tetrahedral for this molecule. But there is only one bonding pair electrons. So in ICL molecule, there are 3 lone pair electrons and 1 bonding pair electron. So therefore, 3 lone pairs of iodine are directed at the 3 corners. You can see here, this is tetrahedron. First, second, third, 3 corners are there. And at one of the corner, chlorine is there. Okay. Directed at 3 corners of tetrahedron, and 1 bonding pair occupies the remaining position as shown in the figure. The 3 lone pairs distort due to the repulsion the tetrahedral structure, and ICL gets linear geometry. Instead of having the tetrahedral geometry, it is having the linear geometry, can be represented in this way. So it means that iodine monochloride, it is having the linear geometry. Okay. So on the basis of this VSEPR theory, we can explain the bond structure of iodine monochloride, that is XY type. Let us see now. Second one, it is XY3. XY3 type interhalogen, where X is less electronegative halogen and Y is more electronegative halogen. Example, it is BRF3, bromine trifluoride. Bromine is the central atom and fluorine, it is the more electronegative atom bonded to the bromine. So let us discuss the structure of BRF3. 3 fluorine atoms are linked to the bromine atom. Bromine atom, it is the central atom. So electronic configuration of bromine and fluorine. So they are having 7 valence electrons. Both are having. So you can see here BRF3, 7 valence electrons. So 1, 2, 3, 4, 5, 6, 7. The arrangement will be like this. Or I would like to show here. BRF3. So 3 fluorine atoms are covalently bonded to the bromine atom. So let us show the 7 valence electrons, 1, 2, 3, 4, 5, 6, and this 7th. Similarly for this 1, 2, 3, 4, 5, 6, and this is 7. Similarly for this 1, 2, 3, 4, 5, 6, and this is 7. Same for the bromine. This is 1, 2, 3. Okay, 1, 2, 3. Then 4, 5, 6, 7. Okay. Now on the basis of this Lewis dot structure, we have to find out the number of bonding pairs. So this is one bond, this is another bond, and this is third bond. So 3 bonding pair electrons are there. And number of lone pairs, these are lone pair electrons on the bromine atom, central atom, 2 lone pair electrons. So steric number, it is equal to 3 plus 2. Steric number, it is equal to 3 plus 2, it is equal to 5. So this is the type of the molecule AB3, E2 type of the molecule. Number of the lone pair electrons are 2. So it is AB3. Okay. So AB3, E2 type of the molecule, this is A bromine, B fluorine, AB3, and lone pair electrons are 2. So on the basis of this steric number is 5. So on the basis of the steric number, the predicted geometry of the BRF3 molecule, it is trigonal bipyramidal. For steric number 5, the predicted geometry, it is trigonal bipyramidal. Okay. For steric number 4, the predicted geometry, it is tetrahedral. For steric number 3, the predicted geometry, it is trigonal planar. And for steric number 2 and 1, the geometry, it is linear. So now in BRF3 molecule, there are 3 bonding pair electrons and 2 lone pair electrons around the bromine atom, around the central bromine atom. So on the basis of the VSEPR theory, valence electron pair repulsion theory, we have to represent the correct position of the lone pair of the electron, and that position will be in such a way that there is a minimum repulsion between the lone pair and bond pair electrons. Okay, so let us see the probable structure. It is trigonal bipyramid. The electron pairs are arranged in such a way that they experience minimum repulsion with maximum stability. So there are 3 possible structures we can draw here. Okay, this is trigonal bipyramid. The 2 lone pair electrons will be at the axial position. This is one, and this is at the trigonal. 3 BRF bonds are there. Now these 2 electrons are onto the equatorial position here. So we can represent the structure in this way also, or this. So out of this 3 structure, now which one is correct? What is the correct position of the lone pair of the electron? Okay, in the position C, one will be at axial, one will be at equatorial position. Okay, so this position, it is correct position, because only 2 BRF bonds, this is one BRF bond, this is second BRF bond, comes in the influence of lone pair electrons, come in the influence of lone pair electrons. Okay, here also the same thing. While if you see this structure, under the influence of the lone pair electron, these 3 BRF bonds comes in the effect. So it means that distortion is greater here. Distortion will be less here. Minimum repulsion between the lone pair electrons, lone pair bond pair electrons. Okay. In this case also, one position is axial and one position is equatorial. It is not correct. Okay. So it means that this structure B is correct. So due to the repulsion between these bond pair and lone pair electrons, the BRF bonds, it is distorted. Some distortion is takes place here due to the presence of these 2 lone pair electrons. So what is the actual structure of BRF3 molecule? So you can see here in structure B, the lone pair interaction is minimum, but the 2 bond pair of electrons causes distortion to the axial fluorine atoms. Causes distortion to the axial fluorine atoms. So you can see here the axial fluorine atom causes distortion. So it is shifted on this side. Okay, due to the repulsion between this lone pair, it moves away. So actually, originally this bond angle, it is 90 degree here between bromine, fluorine. But this bond angle get reduces now here from 90 degree to 86.5 degree. That bond angle will be reduces here. So the 2 bond pairs of electrons causes distortion to the 2 axial fluorine atoms. You can see here, causes distortion. So the structure will be like this. Okay, the structure of the BRF3 can be represented in this way. So it is having the bent T-shaped structure. BRF3 molecule, it is having the bent T-shaped. Due to the presence of this lone pair of the electrons at the equatorial position, these 2 BRF bonds slightly shifted. Distortion takes place. So this bond angle 90 degree get reduces 90 degree to 86.5 degree here. Okay, or 87 degree. So this is the structure of BRF3 molecule. It is having the bent T-shaped structure. So in this way, there is a distortion is occurs due to the presence of the lone pair of the electrons. So in the geometry or in the structure, we have to represent the correct position of the lone pair of the electron. And on the basis of the VSEPR theory, the lone pair of the electrons occupy such a position in a molecule in which there is a minimum repulsion between the lone pair and bond pair electrons. So at this position here, only two BRF bonds comes in the influence. So distortion is takes place there. Hence, BRF3 molecule is having bent T-shaped structure. So that is XY3 type. Now XY5 type, interhalogen compounds. Example, it is IF5 and BRF5. So let us consider the example of IF5. Iodine is the central atom and fluorine atoms are surrounded to him. Okay, so we know the number of the valence electrons for both NH2 NP5. So let us draw here the structure. The structure can be drawn here. So iodine having the valency 7, 1, 2, 3. Okay, 1, 2. It is having the valency 7. Now 5 fluorine atoms are bonded here. Okay, so you can see, or we can represent on this side. Okay, so iodine, it is having 7 electrons. So let us represent first 5 electrons. 1, or on this side we can represent this 2, 3, 4, and this fifth one. Let us represent the correct position of the electron here. Okay, these 4 electrons now, and fifth electron I would like to represent here, fifth. Okay, like this, until 2 electrons are remaining. So 2 electrons will be here, lone pair electrons. Now let us see fluorine atoms. This is one, this is second, this is third, this is fourth, and this is fifth. They are also having the 7 valence electrons. So 7 valence electrons can be represented in this way for each fluorine atom. So there is a formation of 5 covalent bonds. There is a formation of 5 covalent bonds. So we can show that 5 covalent bonds here. Okay. So there is a formation of 5 covalent bonds here. So this is 1, this is 2, this is 3, this is 4th, and this is 5. 5 covalent bonds are there. So this is the Lewis dot structure. So number of bonding pair electrons are equal to 5, and only one lone pair electron, this one, remaining unshared pair electron. So steric number, it is 5 plus 1, 6. So what is the type of this molecule? It is AB5, and only one lone pair is there. So E, AB5, E type of the molecule this is. Which molecule? Iodine pentafluoride molecule. So for steric number 6, the predicted geometry, it is octahedral. So the predicted geometry or expected geometry for steric number 6, it is octahedral. The predicted geometry, it is octahedral. So according to the VSEPR theory, the presence of lone pair of the electron, only one lone pair is there, distorts the molecule to some extent. The structure shows that the position of the lone pair of the electron is here. The 4 fluorine atoms are at the square of the at the corner of the square, and 1 fluorine atom at the axial position, and lone pair of the electron, it is at the axial position. The lone pair of the electrons lying in the equatorial position causes minimum repulsion and shows maximum stability. It is the equatorial position. Thus IF5 has square pyramidal geometry. It is not having the octahedral geometry. According to the steric number 6, it must have to be show the octahedral geometry. But actually in this case, due to the distortion, it is showing the square pyramidal geometry. This is one pyramid here, and this is square. So this is about the structure of iodine pentafluoride, IF5, XY5 type of the interhalogen. Let us discuss now the last type of the interhalogen compound, that is XY7 type of the interhalogen compounds. So represent the Lewis dot structure. Iodine is the central atom here, and 7 fluorine atoms, 1, 2, 3, 4, 5, 6, and 7. So there are 7 bonds. Okay, 7 bonds are here in the IF7. So all the electrons of the iodine are involved into the covalent bonding. No electron is left here. Unpaired electron, no lone pair electron is here. So number of bonding pair electrons are equal to 7. Lone pair electron, it is equal to 0. So steric number, it is equal to 7 plus 0, it is equal to 7. So this is AB7 molecule, AB7 type of the molecule. No lone pair electron is here, as 7 fluorine atoms are covalently bonded to the central iodine atom. So no one electron is left now for iodine. All the electrons are involved into the bonding. Okay, so this is the Lewis dot structure of the IF7 molecule. So the expected geometry will be like this. IF7 molecule, there are 7 bonding pair electrons around the iodine atom, and there are no lone pair electrons here. The steric number 7 suggests that the probable structure is, it is pentagonal bipyramidal. The probable structure, it is pentagonal bipyramidal. This pentagonal bipyramid, two pyramids. This is one and this is second. Pentagonal. 1, 2, 3, 4, 5. Pentagonal. And bipyramid. This one and this one. Okay. So it is having pentagonal bipyramidal geometry. IF7 has. And this is the only one molecule. It is not having any lone pair of the electron. So let us summarize now the structures of interhalogen compounds. Let us summarize the structures of interhalogen compounds. So first one, XY type. Example, it is ICl. Okay, iodine monochloride. So it is having the steric number, it is equal to 4. How it is equal to 4? Number of bonding pair electrons are equal to 1 and number of lone pair electrons are equal to 3. So it is equal to 4. So this molecule ICl, it is belongs to ABE3 type. Expected geometry, it is tetrahedral, but it is showing, according to the VSEPR theory, the geometry is tetrahedral, but it is showing linear geometry. Linear geometry. Hence, we can represent it in this way. Not showing the tetrahedral geometry because there are 3 lone pair of the electrons in the structure. Second type of the molecule, XY3. Example, it is BRF3. Okay. So steric number in this case, steric number, it is equal to 5. That is, the steric number 5, it is 3 plus 2. Number of bonding pair electrons are equal to 3 and number of lone pair are equal to 2. So it is having the expected geometry, it is trigonal bipyramidal according to the steric number. Expected geometry, it is trigonal bipyramidal. Bipyramidal. Okay. Expected geometry this is, but its geometry, it is Benty like of the shape. It is having Benty, means as we have shown here. This is bromine atom and like this, Benty like of the shape. Okay. So this is Benty. Okay, it is bent T type of the shape. Next, it is XY5. Example, it is IF5, iodine heptafluoride. Okay, iodine heptafluoride. So now in this case, steric number, it is equal to, steric number, it is equal to 6. How it is 6? Number of bonding pair electrons are equal to 5 and only one lone pair electron is there. So this is the molecule of the type AB5E. Only one lone pair electron is there. So it is having expected geometry is octahedral according to the steric number. If the steric number is 6, geometry is octahedral. But it is having the geometry due to the presence of the lone pair of the electron. One lone pair of the electron is there in the structure. So it is having square pyramidal geometry. Square pyramidal geometry. And last one, it is XY7 type of the molecule. Example, it is IF7. IF7. And steric number, it is here 7. How it is 7? 7 plus 0, it is equal to 7. No bonding, no lone pair of the electrons are here. All the electrons are bonding pair electrons. So according to the steric number, it is having the geometry pentagonal bipyramidal. Pentagonal bipyramidal. So this is the geometry of the this IF7 molecule, iodine heptafluoride. So in this way, in this lecture, we explain the structure of interhalogen compounds on the basis of the VSEPR theory. On the basis of the VSEPR theory.